Hello! In this video we're going to be talking about triangles. Triangles represent about 7% of all SAT math questions. Now while most triangles equations are at the beginning of each math section, a familiarity and understanding of the triangle equations is critical to succeeding on the math SAT. So triangle questions generally just involve equations dealing with triangles. Nothing too complicated there. From an approach point of view, we want to know that we can look back at these equations. So remember, if you do forget any of the equations we're about to discuss, you can look back at the beginning of a math section to find Pythagorean theorem, the 30-60-90 triangle rule, the 45-45-90 triangle rule, and the area of a triangle. So those are pretty much the equations we need to know. Pythagorean theorem, special triangles, and basic triangle relationships. So while they are at the beginning again, I really need you to know and understand them in order to apply them quickly and accurately. Also, with triangles, don't be afraid to estimate. Oftentimes with triangle questions, if it's too difficult to actually solve for something, you can estimate it to within a very, very accurate level. So the first equation we need to know is that area of a triangle is given by 1/2 base times height. Now keep in mind, this is the perpendicular height. So in the figure that you see here, it might be tempting to do the side times the side. We can't do that. We actually have to solve for the perpendicular height of that triangle. So for a practice question, what is the area of a triangle with a base of 10 and a height of 8? So to do this, we just simply do 1/2 10 times 8, which gives us 40. The perimeter of a triangle is just the sum of the three sides. So if you have A, B, and C as the three sides of your triangle, the perimeter is A plus B plus C. Isosceles triangles have 2 equal sides and 2 equal angles. Oftentimes with an isosceles triangles question, they will tell you the triangle is isosceles, and you'll have to imply that it has 2 equal angles or 2 equal sides. Or they'll tell you that 2 angles are equal. Then you'll have to imply that it is indeed an isosceles triangle, and so the 2 sides opposite those angles are equal. Usually they'll give you one of the 3, and you have to imply the other 2, going through the fact that an isosceles triangle has 2 sets of equal sides and 2 sets of equal angles. Equilateral triangles are a special form of an isosceles triangle where all 3 angles are now equal and they're all equal to 60. Because all the angles are equal, all the sides are equal. So again, they may not tell you it's an equilateral triangle, they may just tell you that all angles are equal. You then have to imply that all sides are equal. Or vice versa, they may tell you that all sides of a triangle are equal, in which case you have to imply that all angles are equal and they are indeed equal to 60. Special right triangles. So there are basically 4 types of special right triangles. There are the 3, 4, 5 and the 5, 12, 13. Now the 3, 4, 5 shows up way more often than the 5, 12, 13. And the 3, 4, 5 can often show up in the form of a 6, 8, 10 right triangle. So be on the lookout for the 3, 4, 5. It's helpful because it saves you time. You don't have to do Pythagorean theorem to solve for the third side of that triangle. The other 2 special triangles show up a lot more, and those are the 30, 60, 90 and the 45, 45, 90. Again, these relationships are at the beginning of the math section, so you can look back. 45, 45, 90, the relationship is x root 2. What this means is that we multiply by the square root of 2 if we're trying to go from a side to the hypotenuse. So if the side of a 45, 45, 90 was 6, the hypotenuse would be 6 square root of 2. If I told you that the hypotenuse was 6, the sides would be 6 divided by the square root of 2. A 30, 60, 90 got the relationship x root 3, and 2x. So if I told you that the small side was 3, the large side would be 3 root 3, and the hypotenuse would be 6. So it's important to understand that these special right triangles show up in certain situations. 45, 45, 90 triangles show up often when you cut a square in half, yielding 2 45, 45, 90 triangles. 30, 60, 90 triangles show up when you cut an equilateral triangle in half, forming 2 30, 60, 90 triangles. So let's try 2 problems that deal with this fact. What is the diagonal of a square with sides 6 by 6? So if we draw a 6 by 6 square and we draw on its diagonal, we realize that what we're looking for is the hypotenuse of a 45, 45, 90 triangle with side length 6. So all we need to do is multiply by square root of 2. So the hypotenuse would be 6 square root of 2, or the diagonal of the square would be 6 square root of 2. Now, if I ask you for the height of an equilateral triangle with sides 4, by cutting it in half, you realize you have 2 30, 60, 90 triangles. Now, it's a little tricky here. The small side is now half of 4, which is 2. The hypotenuse would become 4, and the height would be 2 square root of 3. So again, be very aware that when you split squares and triangles, you generate special right triangles. Pythagorean theorem, probably an equation you're very familiar with. Very good equation to use to solve when you're trying to find one missing side to a triangle. So the equation reads a squared plus b squared equals c squared. Remember, c is always the hypotenuse. Now when you're solving for a side, you're going to have to take a square root. So if you're solving for c, c would be the square root of a squared plus b squared. If you were solving for b, it would be the square root of c squared minus a squared. So if we have a right triangle that has sides 10 and 24, and we said, what is the third side? Now, if you remember the 5, 12, 13, you realize that this is just times 2. So it would be 10, 24, 26. But using Pythagorean to do it, we could say 10 squared plus 24 squared, and take the square root, and that would also yield 26. So Pythagorean theorem is very helpful. And again, it is at the beginning of the math section, but you want to know to use it anytime you're trying to solve for a missing side of a triangle. Angle-side relationship. So you notice when I was talking about isosceles triangles that I said that two equal angles point to two equal sides. Well, that basic relationship holds for all triangles. Bigger angles point to bigger sides. So you don't need to know the law of sines here because they'll never ask you to use that to compute a side, but you do occasionally have to know that a bigger angle would point to a bigger side in that given triangle. Maximum and minimum sides of a triangle. So when you're trying to compute the maximum or minimum side of a triangle, all you have to do is add and subtract the two sides that are given. Every side must be bigger than the difference between the two other sides, and it must be smaller than the sum of the other two sides. So if the two sides of a triangle are 5 and 8, and I said what is the greatest or least integer value possible, we would say that the third side has to be less than 13 or greater than 3. So the answer to this question, if it was the greatest integer possible, would be 12, and the smallest integer possible would be 4. Similar triangles. Similar triangles are triangles that have equal angles. Similar triangle questions often show up in the form of taking a large triangle and cutting it parallel to one side, such as taking a ramp and cutting it in half and asking you what the new height of the ramp is, if I gave you the original dimensions of the ramp. Or taking a cone and cutting it. Anytime you cut a triangle and you create a smaller triangle within it, if that cut was parallel to one of the sides, you get a similar triangle situation. Now, similar triangles have a nice relationship. You can divide the big side of one to the small side of the other for any corresponding set of sides. So in the drawing I have here, big A over little a equals big B over little b equals big C over little c. So let's take a look at a similar triangles question. If the two triangles are similar and have sides 3, 4, 5, and 9, 12, x, what is x? So using the equation, we simply say 9 over 3 equals x over 5. So since 9 is 3 times as big as 3, the missing side would have to be 15, because that would be 3 times 5. So all of the equations, again, are given at the beginning of the section, but it's imperative that you have a good understanding of triangles so that you can use them quickly and effectively. So I hope to see you soon in one of our other math videos. Thanks.